Hello students, I am Sarvesh Kumar Soni, Assistant Professor PSIT Kanpur, and today I am going to discuss multi-dimensional array. So what is multi-dimensional array? Multi-dimensional array is basically consist of array of 1D arrays. It consists of various 1D arrays. It can be also visualized as a matrix. So it is a collection of various 1D array of same data type, right? Array can be visualized as a plane that has various rows and columns. Each row is a single dimensional array. Similarly, a 3D array is an array of 2D arrays, and it can be visualized as a cube that has planes, and each plane is a basically 2D array. So 3D array can be visualized as a collection of various 2Ds, and each 2D consists of various rows and columns. Okay. So now I'm going to talk about two-dimensional array. So a two-dimensional array has its element arranged in a rectangular grid of rows and columns. The elements of two-dimensional array can be accessed by using a row subscript that is called a row index, and another script that is used to access particular element is column index. So we have to select both the indices, row index as well as column index, when we are trying to reach particular element in the matrix. Both the row subscript and column script are required to select a particular element of the two-dimensional array. Two-dimensional array is popularly known as a matrix. So as shown in this figure, this is a two-dimensional array, or you can say matrix, which consists of four rows, 0, 1, 2, 3, and 7 columns from 0 to 6 as shown in this figure. So these are the row indices, starts from 0, and each row consists of 7 columns, and the index of the column starts from 0 also, 0, 1, 2, 3 up to 6. So this is the visualization of our two-dimensional array in terms of C language. So how to declare a two-dimensional array in C programming? So as we have discussed in previous video, where we have discussed about the one-dimensional array, similarly we can declare two-dimensional array as well, in which first of all we have to mention the data type of the array, followed by space, then array name. Array name is basically the identifier. Then after we have to mention two size. First size will be the row size, number of rows in the matrix, and in second bracket consists of the column size, how many columns per row, and equal to the values which are going to be initialized in braces, curly braces separated by comma, and after that put semicolon. So following are the important points about the two-dimensional array. Two-dimensional array declaration consists of a type specifier, that is the data type, and identifier, that is the array name, row specifier, as well as column specifier enclosed in square brackets. Now the following declaration of two-dimensional array are valid. For example, if I am declaring array int arr, this is the array name, and the data type is integer, in which we can store integer values in this array arr, and it consists of two rows, and each row contains 3 columns. So this is the basically matrix of 2 cross 3 order. Similarly, I have declared an array name is brr, and the data type is float, and it contains 5 row and 1 column. Similarly, character array crr of 3 cross 3, and the row size specifier and column size specifier should be a compile time constant, and that must be greater than or greater than 0, right? So as I have told in previous video, in 1D array the size must be integer constant, or it can be macro. Now point number 3 is the specification of row size and column size is mandatory if an initialization list is not present. Fourth point is if the initialization list is present. Actually, if I have given some values to the matrix, the row size specifier can be skipped. If I'm not going to give the value of rows, then it can be skipped, but the mandatory to mention the column size specifier followed by the initialization list. So there are some important points about initialization list of 2D array and the syntactic rules how to initialize a 2D array. First point is the number of initializers in the initialization list should be less than or at most equal to the number of elements in the array. If the number of initialization in the initialization list is less than the number of elements in the array locations are initialized row wise. Some of the array locations that do not get initialized with automatically will be initialized by 0 or 0.0 or \0 according to the data type of the value. Basically these are the default values which are initialized by the compiler. If my array size, my matrix size is larger but I have initialized only few values, then rest of the cell will be initialized by 0 if it is integer type array, and rest of the cell will be initialized by 0.0 if it is floating type or double type array, and if it is character type array, then rest of the cell will be filled by \0, that is the null character. Now point number 3 is the initializer in the initialization list can be braced for each row. Actually we can initialize rows separately. So if we are trying to do this, then we have to enclose each and every row in separate curly braces. Okay, so if the number of initializers within the inner braces is less than the row size, then tailing locations of particular row get initialized by 0 or 0.0 or \0 according to the type of the array. Here I am going to discuss some examples of 2D array. For example, in first case I have declared an array of 4 cross 7 order, and I have initialized some value 2 1 2 3 4 5 6 1 6 1 6 8. So my array will look like this. And similarly, if I am going to declare an array of same size, name is array1, and initialize row wise separate, then first row is separated by using curly braces, and I have given two values in first row, 2 comma 1. Then first row contains 2 comma 1 on, in first two values, and rest of the cell of first row will be initialized by 0 by default. Similarly, in second row I have initialized three values, 2 3 and 4. So 2 3 and 4 will be filled consecutively in the sequential value locations, and rest of the cell will be filled by 0. Similarly, third row initialized by only one value, that is 5. So 5 is stored here, and rest of the row values or row cells are initialized by 0. Similarly, fourth row is initialized by 4 values, 6 1 6 8. 6 1 6 8 are stored here, and rest of the cell of that corresponding row is initialized by 0. So this shows the row wise separate initialization. While in first case I have initialized whole array, then the values in this 2D array or matrix will be filled by in row order. So actually in further slides I will discuss the implementation of 2D array, how the values are initialized. So just wait for next slide. And this is the third array, and the name is array2. So same order, 4 cross 7, and initialize few values. And first row is initialized by 2 and 1, then 2 and 1 are stored in first row, and rest of the cell of the first row are initialized by 0. Similarly, I have initialized second row by 2 3 and 4, then 2, 3 and 4 are initialized in second row, and rest of the cell are initialized by 0. But I have not given the values of further rows. Then other rows are initialized by default value 0, right? So these are some different ways how to initialize a matrix. Now how to access a 2D array? So to access the value stored in 2D array, we have to use row index as well as column index to reach the particular cell in the matrix. So this is the example in which I have declared an array of integer type, name is A, and order of this matrix is 2 cross 3. Values initialized are 12, 10, 3, 21, 32 and 14. Now I am going to print the values of particular cell stored in this matrix. So if I am writing A00, it means it refers to the first value of the matrix, that is 12. So if I am going to print A00, then 12 will be printed over here, right? A10 means the value of first row and second column, okay, that is 10. Similarly A02 means 3, and similarly 1A0. These are some different ways. There is no difference between A10 or 1A0. I will discuss later in pointer concept to explain this type of accessing. Now what are the various memory representation of two-dimensional array? So there are two ways of doing this. Number one is row measure implementation and column measure implementation. So row measure implementation depicts that the values initialized in 2D array are filled row wise, right? So C language by default support this type of implementation, that is C language supports row measure implementation of two-dimensional array by default. That is, if we are initializing the value to a matrix, then initialized values will be filled in row wise order, right? But for example, this is the matrix, right? And the order of this matrix is 2 cross 4, and the values initialized are 2, 3, 1, 4. This is first row, and second row consists of 8, 6, 9 and 17. So the memory will look like this. The array name is suppose A, then contiguous memory is also allocated for two-dimensional array inside RAM, and the indices will always start from 0. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so the values, first of all the first row values will be filled. So that is 2, 3, 1, 4 will be stored in contiguous locations. These are the values of first row, and after filling the first row, then second row will come into the picture, 8, 6, 9 and 17. And as we know that the base address will always be stored in the array name, because array name acts as a constant pointer and it stores the base address. So here I am considering the base address of the array is 2000, and let's say the integer size is 2 byte, then next cell address will be 2002, 2004, 2006 and so on. And in case of second type of implementation, that is called column measure implementation. In this type implementation, the values initialized will be filled column wise, that is first column, then second column, then third column. And this type of implementation are basically used in Fortran, MATLAB languages, but C language supports the row measure implementation by default. So if we talk about the column measure implementation, and my matrix is same matrix 2, 3, 1, 4. This is first row, and second row is 8, 6, 9 and 17. But in case of column measure implementation, the memory representation will look like this. First of all, First of all, the first column will be filled in the memory in a contiguous order, 2 and 8. Then after second column, 3 6. Then third column, 1 9, and so on. So now if we talk about the three-dimensional array. So three-dimensional array, as shown in this figure, a three-dimensional array can be visualized as a cube that has number of planes, or you can say it consists of various 2Ds, and each 2D consists of various rows and columns. So each plane is basically a two-dimensional array. Thus a three-dimensional array is made up of two-dimensional arrays as shown in this figure. So how to declare a three-dimensional array in C language? So according to the previous slide, we have to add on a next value, that is for number of 2Ds. So first of all we have to mention the data type, followed by space, then array name, then there will be three brackets, in which first bracket consists of number of 2Ds, or you can say number of planes. Then second bracket consists of row size, and third bracket consists of column size, and equal to the initialization list. Right, so this is the simple way how to declare a three-dimensional array in C language. So the following are the some important points about three-dimensional array in C language. Three-dimensional array declaration consists of a type specifier, number of 2Ds, or you can say number of planes, row specifier, and column specifier inside square bracket. So this is the basic idea how to declare and how to access a two-dimensional or three-dimensional array. Now I'm going to forward for some important points based on two-dimensional array. So first problem that generally asked in question paper, that is matrix addition. So we know the mathematical process of matrix addition very well. This is the matrix addition process. This is matrix 1 of order 2 cross 2, and similarly matrix 2 is also order of 2 cross 2, and we want to add these two matrices. So the basic idea of matrix addition is corresponding values are added and stored in some new matrix, that is a resultant matrix, right? So 3 plus 1, these are the corresponding element, or you can say that 0 0th element of matrix 1, similarly 0 0th element of matrix 2 will be added and stored in the 0 0th position of the resultant matrix 4. Similarly 4 plus 5 will be 9 and stored in this place. So this is the basic idea of matrix addition. Now if we talk about the programming logic, so this is the logic of C program, how to add two matrices. So first of all I have attached a header file stdio.h by using hash include directive. Then start main function. Then in this function I have declared three arrays. One is A of size 3 cross 3, another one is B, and similarly array C. So, and both are all the matrices are of order 3 cross 3. Two variables are required for looping purpose, I and J. So first of all I have given a message, enter the first matrix. So if we want to read the values from keyboard and store those values in the matrix, we have to take two loops. One loop, basically here I counter variable is used for first loop, I equal to 0 to I less than 3 I plus plus. So this loop is basically used to change the row indices, right? So as we can see there are three rows in matrix A. So the first row will change the row indices 0 to 2, 0, then 1, then 2. Okay, and inside this loop we have to change the column index. So again another loop is required for j equal to 0 to j less than 3. So this j loop basically used to change the column index of particular row. Okay, so here column values are also 3, so this loop also will start from 0 and goes to up to 3, right? And inside this loop we have to use just scanf function, mention the format specifier as %d because this is integer array, and store the value which are given from keyboard in the matrix A. So we have to write down end of aij, ith row and jth column. Okay, so this is the basic idea how to read a matrix from keyboard. Similarly, we have to given second matrix from keyboard and stored in similar manner in another matrix B, right? So again, two loops are required: I equal to 0 to I less than 3 I plus plus. Inside that loop I have given another loop j equal to 0 to j less than 3 j plus plus, and scanf, and stored in different matrix B in this case. Okay, after reading these two matrices, now the process begins for addition of two matrices. So simple idea of addition of two matrices is we have to change the row index as well as column index. So again, two loops are required for from I equal to 0 to I less than 3 for changing the row index, and for changing the column index j equal to 0 to j less than 3 j plus plus. And inside this loop just write down this type of expression: add the corresponding element of matrix A plus matrix B. So we have to write down Cij equal to Aij plus Bij, right? So first of all, corresponding element of two matrices are added and stored in the same location, same indices in the resultant matrix C. Okay, so once these loops are finished, then I will get the resultant matrix in matrix C. Okay, so just print out the resultant matrix in same way, and trace two loops and print the element. And after printing every row, we have to change the cursor in next row so that my array will look like a matrix when we are printing it. Then return 0 and main body close. So this is the simple program for matrix addition, and the output is first of all, enter the first matrix. Suppose I have given these values in matrix 1. So after giving this value, then second matrix is also given from keyboard, and after that we will get the resultant matrix. So this is the output of this matrix addition program. Now come to the most important program, that is matrix multiplication. So it is a little bit difficult, little bit conceptual than matrix addition process, because here some additional work have to do. Because if we are talking about the mathematical operation, what is the mathematic related to the matrix multiplication, so we know very well about the mathematic part of this matrix multiplication process, that first matrix, we have to change the rows of first matrix, and we have to change the columns of second matrix, right? So my first matrix is of order 2 cross 4, right? 2 cross 4. And the matrix B, let's say it is B matrix, and first matrix is A matrix. So A matrix is of order 2 cross 4. Similarly, matrix B of order 4 cross 3. First of all, we have to check the matrix multiplicity. So the condition of matrix multiplicity is if the columns of first matrix are equal to the rows of second matrix, then matrix multiplication is possible, otherwise not. So the process is start one loop for I equal to 0 to I less than number of rows in first matrix. Similarly, we have to change the column, so another loop is required. Let's say it is iterated by counter variables j, so we have to write down j equal to 0 to j less than a number of columns in second matrix. So as we can see, there are 3 columns in second matrix, so j loop will iterate from 0 to less than 3, right? And the basic idea is multiply the corresponding element in these two row and selected select a row and columns and add them all. That is, A11 will be multiplied by B11 plus A12 into B A12 into B21 plus A13 into B31 plus A14 into B41. And once we get all the addition of these terms, then store that value, that final value, in C11, right? So we will get one element in the resultant matrix. Similarly, row is right now again zeroth row is fixed, and change the column. So next time the column index will be changed, so selected column will be the second column of the matrix B, then corresponding element, that is A11, will be multiplied by B12 plus A12 multiplied by B22 and A13 multiplied by B32 plus A14 multiplied by B42, and add them all, and it becomes the second element of the resultant matrix. So this is the basic idea of matrix multiplication. Now if we talk about the programming logic and then come to the programming part of matrix multiplication, just include the particular header file. Stdio is required in this program. Start main function. Okay, now main inside main function we have to declare uh, three arrays: A33, B33 and C33. Actually, for simplicity, I have chosen square matrices of order 3 cross 3, but in general we can choose any user defined size. And three additional variables are required: I, j and k, because three loops are required for matrix multiplication process, that I will discuss further. So first of all, we have to input the first matrix, right? So enter the first matrix, take two loops and change the row index and corresponding column index, and scanf that those values and stored in the first matrix Aij. Okay, now come to the next part, that is input the second matrix also. Enter the second matrix, again two loops are required, and scanf the values which are given from keyboard and stored in another matrix B. So after giving these two matrices, now process of matrix multiplication will start. And first of all, we have to uh, iterate one loop, I equal to 0 to I less than 3. Notice that this I loop will change the rows of first matrix. So as we can see, there are three rows in matrix 1A. Then this loop will iterate from I equal to 0 to I less than 3. Next, J loop is required, which will change the columns of second matrix. So this loop will start from 0 and goes up to 3 number of columns in second matrix. So there are three columns in second matrix B. So this loop will start from 0 and goes up to uh, j less than 3. And next loop, k loop, is required to multiply the corresponding elements of both the matrices and add them all. So k equal to 0 to k less than 3, k plus plus, and just write down a simple statement: Cij equal to Cij plus Aik multiplied by Bkj. Okay, so this is the main process of addition, matrix multiplication, by using three loops. Once these three loops are finished, then I will get the final resultant matrix in our array C. So just print the array C by simple way: from I equal to 0 to I less than 3 I plus plus, for j equal to 0 to j less than 3 j plus plus, and print of Cij, and change the cursor to the next line after printing each row. Then I will get the resultant matrix. So this is the basic idea of matrix multiplication. So the output will look like this type of format. Enter the first matrix. I have given 3 cross 3 matrix from keyboard, and after that second matrix, it is also 3 cross 3 matrix, and after giving these two matrices, I will get the final resultant matrix as shown in this figure. Now come to another problem, that is transpose of matrix. What is the transpose of matrix? So this is the simple program. So transpose of matrix is basically the matrix where we change the rows into columns, right? So the first matrix is, suppose, let's say this is matrix A, and the transpose of this matrix A is stored in another matrix B, right? So this is a 4 cross 5 order matrix, 4 cross 5, because there are 4 rows and each row consists of 5 columns. So this is the matrix A. So the first row of this matrix A will be stored as a first column of the resultant matrix or transpose matrix. So 1 2 3 4 5, this is the first row of matrix A, but this first row becomes first column of the transpose matrix B, right? Similarly, second row will be converted into second column, third row will be converted into third column, right? So we got the transpose of matrix by interchanging the rows and columns of the original matrix. So this is very simple program, just declare in this case actually I am uh, trying to teach how to read matrix of user defined size. So actually I have declared some larger size matrices, like matrix A is of order 10 cross 10, maximum 10 rows, and each row consists of 10 columns, and B matrix is also 10 cross 10 order, and mn variables are used to input the order by user. Okay, so maximum order can be of 10 cross 10. ij variables are used for looping purpose. So first of all, I have given a message to the user: enter the order of the matrix, enter the order that you want to choose, what kind of matrix you are going to input from keyboard. So scanf m and n value, and after that input the matrix of that order that you have entered from keyboard. So suppose you have entered 3 4, so m value will be 3, row size will be 3, and n value will be 4. So actually you will get a 3 cross 4 order matrix from keyboard. So start the loop for reading purpose: I equal to 0 to I less than m rows, and j equal to 0 to j less than n columns, and scanf the value and stored in the matrix A. So this is the process to input the matrix of user defined order from keyboard. Now how to get matrix transpose? So for matrix transpose, start loop to change the row index from I equal to 0 to I less than m rows, and inside that loop change the column, so j equal to 0 to j less than n j plus plus, and just write down a simple statement: the value stored in matrix A at ith row and jth column will become the value of matrix B at jth row and ith column. So the values of row and column index are interchanged in the transpose matrix B. Okay, so bji equal to aij. Okay, this loop is closed, and the transpose of matrix is printed over here. Okay, so let me explain the important point where, when we are trying to print the transpose matrix. So the transpose matrix order will be of n cross m, n cross m, n cross m, right? So the original matrix order is suppose 4 cross 3, then resultant transpose matrix order will be 3 cross 4. So this is the important point that we have to taken into consideration when we are going to print the transpose matrix. So I equal to 0 to I less than n rows, and j equal to 0 to j less than m columns, and print the resultant matrix B. Okay, and change the line into change the cursor into a new line and print the transpose matrix. So this is the basic idea of getting the transpose of a given matrix, right? And output will be of this type. Enter the order of matrix, suppose 3 cross 4. So then again message will be displayed: enter the matrix of order 3 cross 4, and I have given the matrix values. Similarly, after giving the matrix values and press enter, then I will get the transpose matrix as shown in this figure. Okay, so next program is how to print and sum the diagonal elements, right? So I'm talking about only principal diagonal element. Actually there are two diagonal element. This is the principal diagonal element. So the condition of principal diagonal element is the row index and column index will be same. So this is a00. If the matrix name is A, then this element which is stored in this place will be A00, zeroth row and zeroth column. Similarly, this element will be referred as A11. Similarly, this will be A22 and A33. So these are the diagonal elements. So diagonal element have same row and same column index. So this is the basic condition of diagonal elements, right? So if I'm going to make the program to print and sum the diagonal elements, so simply I have declared an array of order 4 cross 4 variable ij for looping purpose, and another variable sum which is initialized by 0 to store the final sum of diagonal element. So first of all we have to input the matrix. So here matrix is of order 4 cross 4. So my I loop will start from 0 and goes up to 4. Similarly, j loop I to j equal to 0 to j less than 4, j plus plus, and in scanf that those values from which are given from keyboard and store the matrix A. Now after this, the principal diagonal element can be added by using same process. For we have to change the row index, we have to change the column index as well, and put a condition. This is the major condition, this is the main condition of diagonal element I equal to 0. So when this condition meets, then we will print the element at that position, that index, and add them in some variable. So finally I will get the diagonal element printed on screen, and I will get the sum of those element as well, and after that print the diagonal element sum, right? So this is the simple idea to get the diagonal element. Basically in this program I have discussed to get the principal diagonal element. Another is non-principal diagonal element, which I have not discussed in this video. Okay, so this will be the program output. So this is the matrix, and the diagonal elements are 2, 5, 9 and 6. That will be printed over here. Then the final sum of these diagonal elements are 22. Okay, thank you.